welcome back to our channel. Today we want to give you a tour of our solar wall, which is a really cool idea to be able to heat our building passively and without solar panels. It was pretty inexpensive, easy to install, and we'd love to give you a tour.
It's also pretty unique. I had some people tell me that they had heard of something like this once. Somebody they knew somewhere down the line had tried it, but didn't really have any details and didn't seem like they'd work that great to me. So this is our full-blown overdone version, and it's been done for a bit now. We haven't really shared on it yet because we really wanted to try it out, and we found some weaknesses and did some refining, and we're pretty happy with how it's working now, so we thought it was time to explain to everybody what we did. So I'm going to get into quite a bit of detail here on how we actually built it, get into some of the finer points. It's not going to be a real long video because it's a simple device, really.
You can totally do it.
You can totally do it. It was more just using the right materials in the right places and taking advantage of what you have.
So let's go ahead and dive in.
The general idea of this wall is we're using the greenhouse effect. So ironically, we're using greenhouse panel with it, but the idea is this is a south-facing wall. It gets really good midday sun. The irony is for filming, we're doing it on a cloudy day. But during a sunny day, you get really good southern exposure, and you use the greenhouse effect in an air gap to heat up the space, and then you pull that heat into the shop. And then that allows you to turn that on and off as you need it. In our case here, we just need it all the time, so we let it run all the time. So what we have, this is a normal pole barn construction. So you have, I think they're like 8 by 8, dimensionally 7.5 inch square beams, vertical, and then there's horizontal stringers on the front of that. And so we pulled all the tin off and built a false wall behind it. And we'll go into details here. I think Katie has some photos she'll be popping up, but we built a traditional style false wall behind it, just 2x4s. On the front side of here, behind the stringers, we hung Durock, so cement board. So this whole wall is cement board behind. We added in some filler blocks where your traditional pole barn style construction would not have boards here. So we're trying to create these air gaps in between these vertical columns, but filled everything in and then shot the whole thing in exterior flat black, something with good UV protection to really absorb all the UV energy we can. And then we hung this double panel. So it's made to be, building your greenhouse, it's made to be a thermal insulator and let as much light through as possible. This is called Clearview 15, I believe. Not really sure what the 15 stands for, but this is the stuff that you can get at your home improvement store for doing greenhouses.
And I can probably link it in the description if you can find
sure.
the product for me.
Because it took me a while looking to find exactly what I wanted. Because you can very easily find this corrugated plastic, that kind of matches the green or the pole barn style steel. Single panel, it does not have good insulating value. This has pretty good insulating value. I don't remember the R value of it, but then we've sealed everything up. So the greenhouse panels on here, we have individual compartments. These vertical columns are 8 feet on center. So we have an air gap in between each. Because we did this as a retrofit, we pulled the steel off. I used some base channel up top, and I actually cut it back a little bit and we stuck them up underneath. So if I were to do this again, we'd have all the steel off. This would go on first, we'd silicone it, put it on, but the way we did it, we just came back and siliconed afterwards, and it does seal. We have no air leaking the inside. So I think the thing to do is to go inside, take a look at how the mechanicals of it work, how we're moving the air through it, and then we can get into a little more detail about how we actually built this thing. Okay, so here we are on the inside. This is that false wall I was talking about while we were outside. So this is a traditional 16-inch on center 2x4 wall that we built just inside of the vertical columns that are your pole barn structure. So we built them right up to the bottom of the main header, and that was I guess you could call it a composite header. It had an air gap in between, so we did a chunk of plywood underneath to seal it off to try and create a totally sealed airspace on the outside. Then this wall was all spray foamed, and then we came back and put in these vents. So the air comes in the bottom, the cold air comes off the floor through this vent, and then it goes into that air gap where it's heated by that space, by the sun hitting the Durock, and then it is pulled through at the top by this fan. This is not the original design, but this is one of those steps I told you that we changed things to, and it seems to work really good. So the way this works, I guess I'll go back to how I was originally going to do this. The way I was originally going to do this is I was going to build a duct setup here. We have 5 compartments. Each one's 8 feet wide. They go all the way down the wall. And I was going to tie them all together. These are standard, I guess you call them duct sizes at the top and the bottom. This would be a cold air return. That would be a normal 4x12 room vent. I was going to tie them together with 6-inch ducts, go to a main header, have a big fan and a thermal switch. And so once the warm air started rising, hit the thermal switch, you kick the fan on, pulled air into the room. I was looking at making that work and realizing that these individual compartments heat up at different rates, so I didn't necessarily want them kicking on and pulling cold air from one section. So then I was going to look at individual fans and individual thermal switches and just do like duct fans. But then I found these. These are AC Infinity register boosters, so they're made for a room in your house that maybe doesn't get enough flow and it's always cold and you want to pull more heat into it. They have everything already built into them. They have a thermal switch in them, they have a variable speed fan, and you can program them to work at different temperatures. So the way this is set up is we keep the shop at 50 degrees. When it gets to 54 degrees in that airspace on the outside, the heat starts to rise, the little sensor picks up the temperature, and it kicks on the fan, starts drawing that warm air into the room. For every 1 degree, it gets warmer out there, the fan kicks up another speed setting, it goes all the way up to 10. So by the time it gets to 64 degrees, it's at full speed, but these individual sections now kick on as they need to, and they're little 18-watt fans, and it works really efficiently. There's not a lot of power involved, and on a, well, okay, we'll put it this way. We are in Zone 3A, but halfway up Minnesota, what do you call it?
Zone 3B.
3B, okay. So we only really get maybe 3 hours of good sunlight during the winter. The sun doesn't even get above those trees out there, so we're getting partial sunlight. And on a sunny day, it's kicking the temperature in here 3 to 4 degrees above where I have it normally set. If we were to clear out some of the trees and get more direct sunlight, I mean, it's really putting out a lot of heat.
And it's only going to get better as the days get longer.
Yeah, so, that was my other point. We are 9 days past winter solstice.
Mm-hmm.
I mean, it's as cold as it gets up here. The days are as short as they get up here right now. And it is putting out heat. And it is very cloudy today, so they're not on, but I've noticed even on cloudy days, they will be running. We'll get enough heat out of it. All right, so let's get into some of the detail on how we actually built this. Like I mentioned, this is an existing building. We had to do this as a retrofit, which I think is going to be the position a lot of people are in. So the first thing we did is we pulled all the tin off this wall. It wasn't that hard. There's just all these 1/4-inch head screws you take out. We were able to reuse most of them. But we had to actually go all the way to the top and take screws out of the roof and get that whole top trim piece out, which is a little bit of a trick.
And we were able to use all those panels for the roof for my chicken coop.
Yeah, so they created more material for us.
That worked out.
But we pulled them out. I figured out a good ending place for the greenhouse panel. We wanted a good solid piece of wood, so basically where that header is on the inside, that was basically the bottom of it where we stopped. And we trimmed all those pieces out, which is one of my least favorite activities. I hate cutting this steel. You're supposed to use a shear. I just used a saw with a metal blade on it, and then I actually flipped them over so that the raw edge was up under the trim so it wouldn't rust. That was my trick. So took all that tin off, got it back on, shorter. This is bottom channel. It's the same stuff that's down here. I had to buy new stuff. It's made to fold all the way around and go against your sill plate. What I did is I actually took a pair of shears and cut it a 1/2 inch up so that these could slide up underneath it. And then I used some standard trim pieces at the end. So with the construction process we had, with the time frame we had, with things we were doing, we needed to get the building back and sealed up with the Durock on so it could be spray foamed. In hindsight, I would have got the greenhouse panel up and then put everything back up. It would have been a lot easier, but in our process, that's how we did it. So once the tin was all done and the Durock was up and we added in all the filler pieces, anywhere that there would have been a gap, we had to put in a board. We painted the whole thing black, cleaned it really good, and then Katie and I spent a few nights hanging these. I think she has some pictures and videos of that. It was not super easy, but not super hard.
It's kind of a fun project.
Yeah, kind of fun project. It goes up the exact same way as this tin, except for these H joiners here where you have to fit them in between. If I can get it pulled out enough. So that was tricky. We had to use what was that? Oh, it was like a scraper. We had to use a little scraper to kind of get up underneath it and get these started. One final thing to talk about here while we're outside. These greenhouse panels have a slightly different attachment method. So we use these traditional rubber back washers that you'd see for a normal steel panel, but then they want, I guess, this bigger washer underneath it. They actually want a 5/8 washer, and you can't buy them, or at least I couldn't find them with the 5/8 washer, so I bought additional 5/8 washers. You have to pre-drill the holes in the greenhouse panel. It's like a 1/16 of an inch bigger than the screw hole size, so you end up going through and drilling holes and putting screws in, and it takes a bit, but once you get going and you use, I don't know, I followed up and just could kind of track up the rows that were here to find the next screw hole. It went pretty slick, especially when you have two people. You have one person go through and pre-drill, the other person follow along and screw.
Yeah, we knocked it out pretty fast.
Yep. That's about all we need to talk about out here. I want to point out this light sensor up here. We'll talk about it in there more. But I did end up having to put a light sensor to control the fans. We'll get into why in a second. But while we're out here, I want to point that out.
So an upcoming project that we're definitely going to need to do sooner than later is taking out this front row of trees that are casting some shadows onto our solar wall. We wanted to expand out this driveway section anyways, so stay tuned for that little project.
This is how we power the solar wall fans. I ran a power line from an existing outlet that we had. It doesn't require much power. I wasn't really too worried about what circuit I put it on. It runs into the switch. I want to be able to turn these on and off. Because they are thermally activated, I had some issues where I had brought the temperature up in the shop to work using an auxiliary heater, and it kicked all the fans on a cold night where it was pulling cold air into the shop. So I wanted a way to shut the fans off, so that's the switch. The other issue I was running into is the fans would run all day, they would pull heat in the shop would be warm, then it would get dark, it would get cool outside, but it's still warm enough in here that it was kicking the fans on. So I added a light sensor that I showed you outside. The issue with the light sensor is go try to find one that turns on power when it gets light. They don't exist. Not inexpensively anyway. So I had to run a relay to reverse the operation. So what it does is the light sensor actually activates when it gets dark. That releases the backside of the relay and it shuts the coil off. It's a normally closed relay. It has both options, but it's wired as normally closed. So when it sees the switch kick at night, it opens up the circuit and shuts the fans off. Then I just ran the wire down the wall and tied it into all the fans. If we go back down to the floor, we can get off our stools. We go back down the floor, you'll notice I ran adjustable inlet dampers on these. The idea was I was going to have that common duct header, and I wanted to be able to control how much heat was pulled from each one. If I had one that was always running cold, I could turn it down, I could balance the system. Since I ran individual fans, I do not need to have these. I could just have normal cold air return covers on there and be fine. It doesn't even really need anything, just something to keep the cats out of there. Really. So in hindsight, I would get rid of this and avoid the complexity, but it's there now, so it is what it is. I guess if I wanted to, I could go shut them all off and cut the flow. I don't know. There's no reason for them. Get rid of them.
Okay, now that you've gotten a tour of the solar wall, how it works, all that good stuff, I figured you probably want to know how much everything cost.
Yeah, and it is not super cheap, but at the end of the day, if you've ever tried to heat a shop of any size, it adds up in a hurry. So my estimation is that it will probably pay itself off this year, just in the heating cost savings we have.
Right.
Looking at the prices involved though, these greenhouse panels, they are by far your biggest cost. Depending on the size you want, I needed a 4x10 sheet because this was just over 9 feet. Those things were around $125 a piece and we required 10 of them. So you have $1,000, $1,200 worth, I think I got them on sale, but just over $1,000 in greenhouse panel. That is definitely your money. The Durock itself Those are like 12 bucks a piece. I don't know, probably had another $500 in those. After that, it's pretty much just some paint and some, oh, the big one, those fans. Those were 65 bucks a piece. I wish I had 5 of those. So all in all, I have probably $2,000 into this wall. But it's, the heater in the shop is hardly running this winter. It hasn't been super cold, but we also don't have real good sunlight on it right now either. So I think as a fixed piece of equipment that is going to continue to operate and not cost us a lot to operate, it was totally worth it. This was really, for me, a trial. I'm going to be building another shop. I want to do this again. I wanted to see how it worked. I wanted to see if it was worth the effort, if it was worth the cost, and I have agreed that it is. It's totally worth doing it.
And worst case scenario, if it doesn't work out, I'm taking your greenhouse panels. Can always find a use for those.
Yeah.
Thanks for being here. If you guys have any questions at all about the solar wall, feel free to ask away in the comments. And don't forget to subscribe so you don't miss out on any of our upcoming projects.
Thanks for watching.
See you next time.